Hi folks, welcome back to my channel. I hope you guys are having a wonderful day. Okay, so let's get into the problem. As you can see here, I've written number 5 over there. That's because this is the fifth video. Well, basically fifth video on LPP using graphical method. I've uploaded 5 videos before this and 4 videos, that is the first 4 videos were on LPP using graphical method. The fifth video which I've uploaded was on theory. It was a theory based video. It was on disadvantages of LPP and LPP using graphical method. So I would recommend you to go back and watch the videos, basically especially the first 4 videos, because I'm actually going stepwise, so it will be easier for you to understand since I'm going in a sequential manner. Okay, for your convenient, I will also put the link in the description box of all the 5 videos. You can check it out. Okay, so let's get into this problem. As you can see, this is max set equal to 3x plus 1.5y subject to x less than equal to 30, y less than equal to 60, x plus y less than equal to 50, and x comma y greater than equal to 0. Formulate LPP using graphical method. So this is the question. As you can see, now I have to start. What is the first step? The first step is convert the inequalities into equality. I'm going to do that now. Let me just write max z once again just for my convenience. It looks good as well because you cannot simply leave that, isn't it? This one will be x equal to 30. This will be y equal to 60. This will be x plus y equal to 50. Fine, this is done now. Now the next step is I'm going to create one rectangular box so that I can get the value of x and y from this. For these two constraint, I don't need any box because already x is given. So when x is given, y is not given. You need to understand that y becomes 0. When y is given, x is not there, you need to understand that x is 0 over here. So I'm going to make one box for just one constraint. By the way, how many constraints are there? 3. 1, 2, 3. And how many variables? 2 variables. Like in my previous video itself, I have said that using graphical method you cannot have more than 2 variables. If you get any question like there are x, y, z or a, b, c, d, like there are more than 2 variables, you need to understand that the sum is wrong. You can equate that like a, b, c, d. If you get a constraint with a, b, c, d like 4 variables, you can definitely equate that, but using simplex method. I will be teaching you simplex method in the future. Definitely first let me complete graphical method. I want you guys to have a crystal clear view. I'm going stepwise. Since I'm going in a sequential manner, you will know that graphical method is there later on. Like I will post around like 10 videos on graphical method so that you will have a complete thorough view about on this topic, and then I will show you the special cases of graphical method. There are few special case sums on graphical method. You need to know that as well because you never know, you might get that in your exam. Okay, so let's get into the problem. I'm going to create this. Okay, so this will be x comma y. So when x is 0, y is 50. When y is 0, x is 50. Okay, now I have to plot this in the graph. Oh, not only this, even these one. So let me just draw the graph now. Okay guys, as you can see, I have drawn the graph. This is the x-axis, this is the y-axis. Let's see the first coordinate. Okay, that is when x is 30, y is 0. So when y is 0, x will be 30. So I'm going to plot this. Okay guys, as you can see, I have plotted x equal to 30 for this one. When y equal to 0, x is 30. For the second one, when x equal to 0, y is 60. So when x equal to 0, y is 60. Let me just plot this. So I have plotted this one. When x equal to 0, y is 60. I have done that. Now for the next one, this one. So when x equal to 0, y is 50. When x equal to y is 50 means this point. And when y equal to 0, x is 50 means this point. Now I'm going to join these 2 points. I have joined the 2 points now. Now my next step is I need to find the IBFS, that is initial basic visible solution. I think by now you should know how to find IBFS. So let me just mark this region. This region is the IBFS. Just by looking at the equation itself, you can easily understand. If you still haven't understood it, I would recommend you to go back to my previous videos and you can check it out. I have explained there clearly. Okay. As you can see, I have marked the IBFS. Now my next step is I need to find the points which are inside, basically which is covering the IBFS. So 1 2 3 4, I know the coordinate of this one, that is 0 0. I know the coordinate of this one, that is 30 0. I don't know the coordinate of this. I'm going to find out. I know of this one, that is 0 50. How are you going to find out the coordinate of this one? See which two lines are intersecting. This one is intersecting, that is x equal to 30, and this one, that is the equation line, that is my x plus y equal to 50. I'm going to equate these two and find x and y from here. I have marked this point for you to understand. This is A, this is B, this is C, this is D. Okay, now I have to find this point. So this point is x equal to 30. I have written that, and this line is x plus y equal to 50. So let's find out x and y from this. X is already there, so if you put 30 in place of x, you will get y as 20. Now let me write all the 4 coordinates. As you can see, I have written all the 3 coordinates. So this are all, this one, like on the left hand side, these are all the x's and these are all the y's. Okay, now my job is, this is x, this is y, this is x, this is y. I am going to put this x and y in the objective function and then find the value of x for each of the coordinates. Okay, for each points. Now what was my objective function? Look, this is my objective function. So what was the first coordinate? 0 0, that is x is 0, y is 0, so z will be 0, right? I've written 0 over here. Then for the next one, that is x is 30, y is 0. If I put this in the objective function, that is obviously this portion will be 0, and that was 3x, so 3 into 30, that is 90. Now for this one, that is 30 20, that is 30 into 3 plus 1.5 into 20, so we get 120. And for the last one, that is 0 50, so if I put this in the objective function, then 1.5 into 50 will be 75. Now I need to find the objective value, the optimized value. The optimized value is 120. Why? Because out of 0, 90, 120 and 75, 120 is the highest. Okay, so 120 becomes my optimized value. So why are you taking 120? Because my question is again max. Max mean I need to find the maximum among this. Okay, so let me write it. Look, I have written here. So my optimized value is 120, where x equal to 30 and y equal to 20. So this is my ultimate answer. Thank you so much for watching, guys. But before leaving, let me tell you, in my next video I will come up with another graphical method sum. So stay tuned for that. Thank you so much for having so much patience and watching my video. I really appreciate that. Thank you so much, guys. Bye bye.